Hello everyone, my name is Alexander Zelenin.
Hello to everyone, my name is Alexey Khaletsky.
Today we will start to solve problems related to dictionaries and hash maps. Previous part with the arrays we complete successfully. We solve all the tasks with optimal ways and so on. The difference between array and dictionaries, that array is the group of data that's sorted, like from 1 to n. And dictionary have names instead of keys. So instead of just 1, 2, 3, 4, 5, we can name it as we want, like Alexei, Alexander, and so on, and add any value to this. But the thing with the dictionaries and hash maps that they doesn't store the order of things that we assigning. So they by itself do not guarantee to you that you will have all the keys in the order that you inserted to the object. So let's go. Hopefully we will able to solve 2 easy tasks today, since I think we are in a good shape now. At least I am. So we have the first task, the first problem, about ransom notes. If you want to read the whole text, set the pause and read it, and I will just explain it by my own. So we have a kidnapper who tried to use magazines.
Harold Kidnapper, blин. It's very funny problem.
So he tried to use magazines to write messages, write ransom notes, but he want to use whole words. So he, for example, he want to write a note attack at dawn, and the magazine contain only the same word but with different case. So here is like small letter. It will not work, and we will need to answer no. If we will have all the words is required for the note itself, then everything is fine. So task is to complete the function and print only yes or no if it's possible, to write his note with the magazine that we have. Then we write yes. If no, then no. Here is another examples. We have magazine with the phrase "Give me 1 grand today night," and we want to write a message like "Give 1 grand today." Since in initial one we have "Give 1 grand today," we can write our note without problems. Another example: 2 times 3 is not 4. We have 2 times and then we have 2 again. We doesn't have word 2 second time in our magazine, so we will not able to write this note. So we will need to answer no in this case. And another example, I've got a lovely bunch of coconuts. I've got some coconuts. We can write this since, we cannot write this because there is no word some in initial one. So how you think we can solve this problem? How you will solve it by yourself if you will want to write a ransom note?
Well, maybe I give to every word some constant
Okay.
and then compare with another phrase. I take the first phrase, give every word a constant, then compare it with a second phrase, and if these words are in another phrase, it's yes.
Okay. Uh, you are very close to proper solution, but since we doesn't solve anything with dictionaries, I will explain now how we can do this. So we have dictionary where we can put anything as a key. So we will use the words as a key, just as you told right now. And we will have some counter to count amount of these words. Then we will go through or maybe we can start with the second note. So we will count, for example, that we have one give, one grant, and one today. Then we will go through the second one, and we will remove all words. We will decrease the counter until the counter will be 0. Or no, I think will be easier to go with the first one and then with the second one. But we'll make some optimization later on, but I think that's fine. So let's see what constraints we have. Each word consists of English alphabetical letters from A to Z, from small letters and big letters, M and N. Number of words and in magazine and note. The number of words is between 1 and 30,000. Okay. So let's do this. We will create words. In JavaScript, both dictionaries and hash maps, like is same things. We have an object where we can put our keys. Then we will go. We will need to split One second. Magazine is array already. No, let me take a look at the sample input. So we have two numbers, then we have words. So I just want to explore what is incoming here. So we parse the first number, we parse the second number, then we parse magazine and parse node. It's already split, so we have already an array of words. So we don't need to split it. So we can just go through all of them, and we will put our word in our dictionary. So first of all, we will need to do something like this. Sorry. We want to increase counter by 1. There should be 0. We want to increase counter by 1, and if this word doesn't exist in our object yet, we just assign 0. Okay? So we create our dictionary. And now we will go through our node. For this, I will use a cycle. while we doesn't go to end of this, we will increase I by 1. I want to use cycle since I want to make a return here if we cannot write our letter. So we will have here some condition, and we will have like a return no. Okay, now from capital N, and let's take a look. It's not enough to just return. I think we need to print. So I just want to avoid some small mistakes from the start. Yep, let's do like this. So we will able to return value here. And if there is no problem, we return yes. So what we will do here, we will take counter, no, not the counter, word count, word count equals to words note I. No, let's do a bit different. First of all, we need the word itself. Okay, so we got it from the node. Then we'll have like the same approach. If it doesn't exist, or amount of words left is less than 1. Okay. If everything is fine, we will decrease amount of the words by 1. Okay. I presume that this is all, and we can just run our code and see will it work or not. Node is not defined. Okay, this is just a typo. It's not an error at all. So, but okay, I still not able to solve it like from first, even for easiest one. So, like everything is fine. We are in great shape. We got high score, no problems here. So let's see what complexity we have. So space complexity and time complexity. Space complexity is how memory change depending on the incoming variables, and time complexity is how CPU usage is changed over time again, depending on incoming variables. So for space complexity, right now we have an object here, and to this object we will store every word or every word from the magazine. So the size will be equal to amount of words from this magazine. Like in worst case, this magazine will be like 1 letter words, and there will be a lot of these words. So the size of our array can be up to the size of the magazine generally. So it will be equal to magazine length. I think for this was use letter M, right? So it will be OM. We doesn't store anything else. We just go through an object and so on. So for space complexity, that's all. We store only 1 object, and that's all with some numbers. For time complexity, first of all, we go through every words from magazine. So we have OM here for time complexity. And in this case, we have ON here, since we go through every node. There is no, like everything inside have a complexity of O1. So we can just summarize this, and we will end up with OM plus N. Okay. Generally, we can make some optimizations here. First of all, we can go through. First of all, we can test a length of both variables and take a look that we doesn't have enough letters, for example. Then if we have in Node 5 words and in magazine we have only 3, we obviously will not able to write independing on what is inside. It's like first optimization, but it will not change the algorithm complexity, and we want to think if there is something that can change. So for space complexity, the thing here with the previous condition that node is always has less words than magazine, less or equal. So we probably can go from OM to ON by storing the words of node and removing them when we will need to do this. And we have time complexity. We will anyway need to go through every word in node, but we will able to complete our function like at the moment when we find every word in our magazine. But again, in worst case, we will end up with the same. Like if we will need to go to the last word in the magazine, we will end up with the same time complexity. But space complexity is better. Space complexity is obviously better. So let's try to do it very quickly. We will take a look that node length is higher than magazine length, and in this case we will return no. Then we will go through nodes. Yes, nothing else changed here, and we will increase here. Let's add another variable, words count. It will be equal to node length, and we will remove from like both of them. So then we go through our magazine instead of node. We have current word, and we will not return no here. There will be some condition, and instead of no we will return true. Oh, sorry, not true. Yes. And if it doesn't find all the words, we will return again no. So if I think there will be two conditions. The first condition that we can take a look that this word is exist in our object, and if it exists, we will take a look that we have enough no, sorry. Sorry. Just
no problem.
Yeah, you're always welcome. we will reduce count of these words by 1, and also we will no, sorry. We will return the count of these words by 1 only if it's greater than 1. So if it's greater than 1, then we remove this word and reduce word count also by 1. Okay, then we can check that word counts equal to 0, and if it's 0, then we complete our note and everything is fine. Let's check our code. It doesn't work by some reason. We will check why it is. So let me just check it again. We add every word to words dictionary. We increase counter by 1. Sorry, if count is greater than 1, obviously. We need to reduce if count of words is greater than 0 and not 1. Because like we need to... Okay, it failed. It fails. Let's think. So we got a new word from the magazine, and we take a look at our dictionary. If what is this? I forgot to remove this line. And it's just a luck that the previous case was work without a problem. So I forgot to remove the line from the previous algorithm. That's all. Happens sometime. So it will be better to like remove all old code and write it from the scratch instead of inserting in the middle. So our algorithm is completed, and right now we have space complexity of ON, since we store the words only from the node, and N is lower than M, so we are in a better shape. But for time complexity, we're still going through all the words from the node, then we go through all the words in magazine. But in some cases, we will end up in less. So this algorithm will be faster, since it's possible to find all words before we go to the end of our magazine. For example, if we have like 30,000 words and we want to write note with like 2 words, like cash now, for example. When we found these 2 words, we done. Everything is fine. So we can go to the next task and take a look what will be here.
Let's do it. Mon general.
We have task called toStrings. And it's on Russian. Okay, sorry. It's possible to... Will it be updated? One second. Why it's on Russian? How to... Sorry.
Chinese works.
It works with Chinese. So for some reason in English it has...
Try to open in incognito mode.
Let's see. Looks like it's the same. Yep. So by some reason, okay, I will
That's weird.
I will translate it. We have two strings A and B. We need to find non-empty strings that exist in the string A and B as a substring. The input format. In the first string, we have the integer t, a count of tests. Then we have tests itself. Every tests have two strings. First of the strings is the string A, and second is the string B. Output format. For every test, we need to write a yes or no. Sample input. Hello world. Hi world. So we have two cases. Hello world and hi world. And we need to print yes for hello and no for hi world. Explanation. Every string have symbols of Latin alphabet, and here we have letter L that exists in both of them. So since the letter L is like substring of hello and substring of world, so we are fine here, and so every test have up to every problem have up to 10 tests, so minimum 1, maximum 10, and the count of letters in every test is up to 100,000. Okay. Alexei, what you are thinking about this task, how we can solve this?
Well, that's weird because we are originally Russian speakers, but I really don't understand what is the problem in this task. What tests? What I don't understand. What this task? What should I do?
Okay. If I will explain you, I will give you an answer. But generally, we have two strings. First string is hello. The second thing is world. We need to find another string that consists in both of them, in the string hello and is in string world. So, and we have that string. It will be just one letter, L. The L exists in word hello and in word L, and in the word world. So
yeah, well, the letter O too in a hello in a world.
yes. So we have such string, then we can answer like yes. In next example, hi world, world doesn't have letter H and letter I, so we cannot answer that it have any shared substring.
Why we compare hello in world and hi in world?
We have two cases. Every case is two strings. One string, two string. So we have two cases. They are independent from each other.
Well, yes. Now I understand. I think can we put somehow these letters in memory?
Yes, like we can use dictionary.
So we just put every letter, for example, H to the memory, then E to the memory, then L to the memory, then O to the memory, and compare with the next word. For example, we compare W with these letters in
Is it
memory.
exist in memory? Then we answer
Yeah,
yes.
yeah.
Yeah.
We need just one
Yep.
compare. Yeah. So when we compare L with these letters in memory, we can print yes.
Okay. Okay. The thing here, I just want to talk a bit about optimizations and so on. Since we have only small letters and there is just only 26 of them, there will be no huge memory consumptions or whatever, and we can stop our algorithm when we fill it with 26 letters. So let's do this. Also, I think we can store in memory the string with the lower amount of words, but for now it doesn't matter. So let's create an object letters, and let's go through string 1. So we will have totally same thing with the previous task. We'll have letters, letter, but in this case we don't need to count them. We need to find only one. So we can use boolean value instead of integer, since we will have do we have this letter? Yes. Do we don't have this letter? No. Okay, that's all. We don't need to count them in this case. And right now we will go through second string. Up to end of the string, and we'll have also letter equal, and if this letter exists, then we can return what we need to return. Yes. Sorry, not. Yes, we can return here. Yes and no. All of them should be capital ones. And we return no if it doesn't exist. Let's take a look what we have here. And here we already have write, so we don't need to modify initial code. So I presume that's all. Let's try.
Fail again. Hooray.
What is S1? S1. Sorry, we need to do it like this. So I will initially we have a strings, and or we cannot change it to arrays. Okay, I will just do the same cycle as we have here, and that's all. So but just for S1. So the thing that we have a string initially and not an array, and the string by itself doesn't have for each function. So we just need to change our code to work with the strings. So looks like everything worked good. All tests passed without problems. So yay!
Congratulations.
So we solve our task. Now we need to take a look what complexity we have here. So we have space complexity and time complexity. Can you try to count them by yourself this time? Alexei?
Excuse me, I don't. Okay, can you ask again?
Yes. Can you count space complexity and time complexity of this algorithm by yourself this time?
Well, space complexity.
What data structures?
I think. Huh?
Yeah. Told, please.
I think it's 0n.
It's not 0, it's big O.
Oh, why it's big O?
Because the space complexity is like big O. It's just called this.
Okay, on.
Okay, but why you think that it's on?
Because here we have nothing to really to use in space. We just one how would say just one. We use this
Dictionary
dictionary in последовательном
sequence.
sequence
We
calculation.
have only one storage here, which is object, and we put every letter from our string to this object. But here is one thing that is important here. Originally, since we are doing like this, we can go with the on, but we have initial condition that all strings consist from the Latin alphabet symbols and all of them small ones. So there are only 26 of them, so it's fixed size. 26.
So it's O26?
Yes, but 26 is also 1. Since it doesn't change, so we're talking about like how fast it grows, and it doesn't grow at all. It okay, if there will be like a small string, it will grow, but up to 26. But we can like start with object with 26 of them, and it will not grow at all. So space complexity will be O1. That's originally a very interesting thing, because without a condition we will end up with on, and I think through all the time it's like the first case when we have such condition. No, it's not the first case. I think we previously have something like this, but for time complexity. But okay, and for time complexity,
Well, I'd say O2 because we have only two scripts to calculate.
okay, let's go through them. What will be complexity for this cycle? How many times this cycle runs?
1.
No, I mean how many times this code is repeated in the cycle?
26?
Not 26, but it depends on the length of the first string. So we go from 0 up to S1 length.
So it's 5? How many letters in this word?
In this case, yes, it will be 5. But in meaning of time complexity, we'll write like OS1N. So string 1 length.
Mm-hmm.
And for the second cycle, it will be
S2 length.
yes, exactly. So, like in worst case, we go through every letter in both of them, and we end up with 2 cycles. And the complete time complexity will be
S1 length plus S2 length.
yay! That's correct.
But it's very abstractive, no?
That's what about all the programming languages. It's about very abstract things. But generally we have like 2 strings. In this case, they are 5 letters, but they can be like 100,000 letters. And time complexity explain how many operations we will perform depending on the incoming variables. So we have 2 incoming variables, S1 and S2. So generally both of them will affect, let's call it S1 and S2. Okay. So if right now we have 5 symbols and 5 symbols, we end up with like 5 and 5 of 10 total operation. But if we will have 100,005 symbols, for example, we will end up in this case with 105, right? Or 100, 100,000 or whatever. So it will change depending on the schema that we describe here. So if this string change, the complexity, not the complexity, the time consumption is changed also. If there will be like 1, it will mean that the time complexity is not changed independently from, like, if we have super large strings, it doesn't change anything. But for us, is change something? Yes.
Yes.
So we had solved 2 tasks today. I think it was very nice. And we left with 3 more medium tasks that we will try to solve tomorrow, at least one of them.
Okay.
Thank you for watching today and have a nice
Thank
day.
you for explaining today.